Hey folks, I guess we are live. Please, can you confirm in the live session window if you can hear me? So that it's good, so that I know that everything is working as expected. Can you folks please confirm on the chat window if you can hear me and see my screen being shared? Right. So those are the two important checks that we need to do before we dive in. Hey, good evening, folks. Thanks for joining in. I'm just waiting for the session itself to start. Object-oriented in Python for AI. Yes, that's the session. Yeah. So yeah, I guess we are live. Yeah. So can you please confirm if you can hear me and see my screen being shared, so that I know that it's working in the first place. So am I audible? Is it clear that I'm audible? Yeah, sounds good. Okay, thank you folks. Thank you for joining in, and let's wait for a couple of minutes. We are a few minutes early. I'll start the session at 6:02 or 6:03 p.m., right? So that everybody joins the session. Everybody who is planning to join can join the session. And we're just going to continue the same way we have done the previous live sessions. This live session is all about object-oriented programming. I'll take a IPython notebook and go through various examples, and let's try to make it a little interactive also. Sounds good. So everything is fine. Cool. So somebody asks, okay, I'll take a few questions. Whatever I can answer, I'll try to answer. Which programming language is best to crack placements? So I'm assuming this is for software engineering roles, not for machine learning roles. For machine learning roles, people mostly prefer Python. There are some companies that use R also, but Python is the most preferred. If you're talking about placements for software engineering roles, I mean, you can use any modern programming language, C++, Java, Python, doesn't matter. Because most product-based companies are fairly neutral to what programming language you use, because they know that the programming language that you know today may not be the one that you'll be as I went, right? But a small catch there is there are a few finance companies which specifically ask for C++ based programming, because most financial companies like trading companies who do high frequency trading, they typically write most of their code in C++ or C, right? So they might have a language preference, but most other product based companies, they're neutral. Like in most of the interviews that I have been part of as an interviewer or an interviewee, in most product-based companies, there was no specific requirement that I should be good at Java or C++ or Python. Because if your conceptual knowledge is good, you can pick up a language in a very little time. Of course, you'll not become an expert in a language, but you can pick up a language and start writing code in just a week or two, right? So it really doesn't matter as long as it's a modern programming language. My personal preference is Python, or some people also like Java, but my personal preference is Python because Python has a lot of very good inbuilt data structures, a lot of nice libraries that we can use. And most importantly, Python also, the code is much more concise, much more easy to write than C++ or Java. So I personally prefer Python. Okay, so somebody is asking, is C++ necessary for data science? C++ is used in a few instances, but only in a very few instances. Python is the most preferred language today for most of data science and machine learning. There is C or C++ being used only when you require, like I have used C++ when we had to write some extremely low level code for speed, right? We had to build a system wherein we need to evaluate a machine learning model in just under a millisecond, right? So when you have such latency requirements, when you have to write code that works extremely fast, there are a few instances where C or C++ is used, but mostly it is Python, and the preference for Python is because of availability of great libraries for data science, statistics, machine learning, deep learning, plotting, you name it. Python has some of the most extensive libraries, and hence even for our courses, we prefer Python over others. So, okay. So somebody is asking, how will the job market be after the coronavirus? Again, I think I mentioned this in one of the previous live sessions also. We don't know yet, right? So the International Monetary Fund says that most likely Most large economies of the world are already in a recession, but we have to wait for this scenario to clear. Again, these are not in our hands. These are large macroeconomic effects that you and I do not control. So my suggestion to anyone, I mean, this is something that we have suggested to all of our students. This is something that I've suggested to all of my employees, to all of my colleagues and friends, that this is if there is a recession, we don't know whether there is a recession because there is a technical definition of what a recession is, which is basically 2/4 of GDP fall in a macroeconomic framework. Again, even if there is a recession, we don't know how long the recession will stay. It might so happen that we have a vaccine for coronavirus, or we have a good medication or a drug, and things become normal very quickly. So we actually don't know. So in times of uncertainty like this, my suggestion is, since you can't impact this, stay safe. That's extremely important. Your job is to ensure that you're safe and build on your skills. Become a better programmer if you want to become a software engineer. Again, even if there is a recession, there are always jobs for extremely skilled people. You might say, how do you know it? Because I graduated at the peak of recession. I graduated in 2009 May, which is literally the peak of the last major Great Recession. It's called the Great Recession now, right? So I've been through one recession in my professional career, and I know firsthand that people who have skills will survive this. People who don't have skills will fall behind. So since you can't control the macroeconomic effects, but you can control what is in your hand. What is in your hand is your time. Of course, your safety most importantly, number one. Number two is your skills. Focus on your skills. Even if there is a recession, even in a recession, there are jobs. There are just fewer of them. So if you are better with your skills, either in programming, machine learning, data science, you will still have jobs. Like one of our students, right? Even during this lockdown period, his interview with Amazon just started before the lockdown. And thankfully, even during the lockdown, all of his interviews got through. He got a confirmation that he's hired. He'll most likely get an offer letter, right? So top companies are always looking for highly skilled people. So if you have skills, don't worry about it. And if you don't have skills, you should focus more on building your skills than panicking. Because if you panic, nothing is going to happen. You can't change the big macroeconomic or the large healthcare systems. You can't do it. Your job is to stay safe and build on your skills. If you have skills, try to improve them. If you don't have skills, gain those skills. That's what I would personally recommend, right? So again, I've seen I've seen this query multiple times. Instead of panicking, what do you get by panicking? You'll become more depressive. That's it. So don't panic. Build on your skills. Again, even in the last recession, people who focused on building their skills, who improved their skills, were the ones who got the jobs, even in a recession and after the recession. As soon as the recession as soon as the world got over the recession, those are the people who got the jobs first, right? So it's as simple as that. Okay, sounds good. Oh, we are already 6:05. So let me get into the live session itself. Okay. So again, I'll try to take more answers later on. So somebody is asking, how is this session useful in ML? So I'll tell that. Wait, please wait. So what we have been doing in the last few live sessions is we have been working on improving the programming skills. Our core focus was how do we improve programming skills of folks? Again, what we have seen is this is where a lot of people lack. This is fundamental. If you know all of machine learning, data science, all the mathematics, but if you can't write reasonable code, nobody is going to give you a job. Let's be clear about it, right? Programming skills is a mandatory thing. So the purpose of this is to cover programming skills in the context of machine learning and AI. Okay. So again, please understand that we are going to build on top of the previous live sessions. So I'll not be repeating the concepts that we have covered in the previous live sessions. I'll be taking a few examples from the previous live sessions and continuing, right? So let me give you an overview. Again, I'm not assuming that you guys know object-oriented programming in any language. I'll not assume that. And I'll assume that you don't know much of object-oriented programming in Python, C++ or Java. And I'll try to explain these concepts from very basics, right? The other concepts, I already assumed that you knew some. You knew some and we were solving problems. In this live session, I'll try to explain the concepts of object-oriented programming with simple examples, some toy examples, some real world examples. Okay, but I'll build on top of the previous live session examples. Okay, first and foremost, broadly speaking, you have procedural languages like C programming, and you have object-oriented programming languages like C++, Java, and Python. Right? Most engineering students learn C. I think it is mostly computer science students who learn C++, Java, and Python. There are also some electronic students also who learn some of these object-oriented programming languages in some universities. So first and foremost, something that you have to remember is you can build large and complex software in procedural languages. You don't require object-oriented programming to build complex large software. For example, take the whole Linux kernel, which is basically the heart of the Linux operating system. Right? Similarly, take the heart of Macintosh, your Mac OS. They both are built in C. C is not an object-oriented programming language, remember. Right? So large complex software can be built in C programming language or procedural programming languages. Now you might say, then why the heck are we learning? Why did these object-oriented programming come into existence? Because again, when people were designing software using C, they realized that as the complexity of the software increased, it became much harder to build systems using C programming language. So object-oriented programming is basically a concept in programming language design. Okay, so this is basically a way of writing code, and object-oriented programming came into existence because it is easier to design object-oriented programming code, especially for large software. And remember, over the period of time, modern software, you have hundreds of contributors, hundreds of software engineers working together and things like that. And it's also much more easy to reuse components. Of course, you can reuse some stuff in C also, because functions is a way to reuse, right? Functions, if I write a function, I can reuse that functionality. But object-oriented programming is much more easy from a design standpoint, and it makes the life easier to build large and complex software. But please remember that you can build large and complex software even in C. Again, Linux kernel itself has hundreds of developers who contribute source code. It is possible. Object-oriented programming is just makes your life easier. Okay, that's the most important tenet, right? That's why if you look at any major module, for example, we use NumPy, right? We use NumPy. NumPy is a very good library of functionality for numerical analysis in Python. We have seen this in the previous live sessions. So NumPy is built using object-oriented programming. So most of the libraries and modules in Python, most of these special purpose libraries like NumPy, SciPy, Matplotlib. Again, Matplotlib is a very popular library for plotting, right? So similarly, you have again there is TensorFlow, right? TensorFlow is used for deep learning. So many of these large complex pieces of software are often written using object-oriented programming, so that it's easier to maintain, easier to design, easier to reuse components and maintain this large complex software. Now, as a machine learning engineer, why should you learn it? That's the next question. First, let's see, as a software development engineer, if you're looking for software development engineering roles, you should know object-oriented programming in good detail. Because as a software engineer, you will mostly be implementing software, or you'll be implementing a small submodule, right? You'll be implementing a small submodule or a class. So if you're a software development engineer, you should know object-oriented programming in quite some detail, right? Because you will be working in large teams where each team member might be building a class or a set of classes. So it's extremely important if you're a software development engineer in modern companies. Now for machine learning and data science roles, again, I have used object-oriented programming, but not as much as software development engineers. I've reviewed lots of code from other software development engineers in my own career. But as a machine learning and data science, being in machine learning, data science and research roles, the application is simple. You should know the basics of object-oriented programming so that you can use various other modules and libraries that people have built. For example, I just showed you an example, right? As a machine learning engineer, or even as a data scientist or a machine learning scientist, you use NumPy, SciPy, TensorFlow, Matplotlib, scikit-learn, right? So you use scikit-learn, XGBoost. These all are extremely popular libraries that are used every day by machine learning and data science folks. They're used day in and day out. Now, when you are using, let's say, NumPy, if you don't know what a class is or what an object is or how inheritance works, you will be limited by how well you can use this programming language, right? So mostly for machine learning and data science roles, for people who are not writing production code, right, you should know the basics so as to use other modules and to extend these modules when needed for your use cases. As a machine learning or a data scientist, if you are writing production quality code by working with software development engineers, you need to also know how classes, how do you write a class, how inheritance works, some of those details. So even from an interview standpoint, if you interview at top product-based companies, especially for software development engineer roles, there is some focus on object-oriented programming. For machine learning and data science roles, there is less focus on it. There is focus on programming in general. For example, we looked at recursion, we looked at some simple programming exercises in the last 6 live sessions, right? There is that focus, but not so much on object-oriented design or object-oriented programming. Again, the true power of object-oriented programming can, of course, you can learn the theory, you can learn a few examples, etc. But the true appreciation, like I learned object-oriented programming when I first learned C++, right? In school days, right? Then I learned a little bit of Java, I learned Python, I learned C#, I learned a bunch of programming languages. All of them, I knew the concepts of object-oriented programming, but I only appreciated why these concepts exist and how they are used when I learned about object-oriented design, right? And you learn object-oriented design when you design large pieces of software. For example, imagine if you're designing a library for plotting, like matplotlib, right? So suppose imagine this is a very popular library for plotting in Python, right? So if you want to design matplotlib, how do you define each of your classes? What are your classes? How do you design what inheritance? How do you design the whole classes and how do you design the whole architecture of this library? Okay, that's where you will really appreciate it. Again, I cannot cover object-oriented design because it's a full-fledged topic in itself. It's a topic mostly in software engineering. I'll not be covering it, but my focus in today's live session will be basics of object-oriented programming for machine learning and data science roles. So if you're looking for software development roles, some of what I'm discussing is useful, but you should build on top of it, right? So the prerequisites that we have are previous live sessions in this series because I'll be using examples from that. Cool. First and foremost, let's make sure what is our what is our Python version, Python 3.7.3. I just want to make sure so that we are not writing code in Python 3. We are writing code in we are not writing code in Python 2.7. We are writing code in Python 3. Just wanted to make sure. Now, in the previous live session, we wrote a URL shortener. We implemented something called as URL shortener, if you recall, using dictionaries and other stuff. We've discussed that in the previous live session in lots of detail. Okay, we actually implemented it using basic inbuilt data structures that are available in Python. Now, the same code. So what we implemented in the previous live session is a non-object-oriented programming, also called as procedural implementation. Again, I've just pasted what we've implemented previously, right? I'll just go through it quickly for those who may not have attended the previous session. I'm creating a dictionary here to store all the long URLs and short URLs. Again, I've shown an example, right? Tiny URL example. Again, this is a very real world problem, right? And we solved it using dictionaries and simple code. So on this, I have two functions, which is get short URL, which given a long URL gives me a short URL, and get long URL, which takes a short URL and gives me the long URL back. And we just implemented it using dictionaries. And I argued why we use a dictionary here, why not a list, why not a set, what is the appropriate data structure here and everything. Now, in the previous live session, I said, look at this. Logically, if you think about it, what do you have? You have D, which is a dictionary, right? And you have two functions. You have two functions, get short URL, right? So get short URL and get long URL. Right? So these are, again, we actually built a simple URL shortening system, right? So if you realize this get short URL is working on this data structure, this get long URL also uses this data structure. So I said, since all three of them are interrelated, why don't we put all three of them into a logical group or a logical entity? I said that's what is the foundation of classes, right? So a class basically is a logical grouping. Again, I'm telling it in a very high level, right? So logically, since I have a variable here, right, and I have two functions which are operating on this variable, why don't I group all of them into a logical entity? That logical entity is called a class, right? So let's actually see the code on how to convert this procedural code into a class. Okay, first and foremost, before we go into it, remember this analogy that I mentioned in the previous live sessions also. If you have a data type, right? A data type has a variable, right? If you have a data type or a data structure, right? For example, imagine if I have I equals to 10. Now what is this? I is a variable, right? I is a variable here. What is the data type of I here? I is an integer, right? That's what it means. So I have an integer, which is the data type, and my variable itself is I, right? Now, just like a data type exists, a class is same as the data type, if you think logically. Instead of saying class variable, we say object, right? So the analogy is important. Just like a class, look at this, just like a data type has a variable, a class has an object. So in some textbooks, you might see that an object is an instantiation of a class. What does instantiation basically means? It's just a fancy English term. What it means is, imagine if I have an int is my data type, I'm creating a variable for int. So when I do this, what happens? In my main memory or RAM, right? In my RAM, there is memory location, there is memory location allocated wherein I can store this value 10 here, and I can refer to this memory location using I. Right? So effectively what's happening is a variable, they call it instantiation because when you create a variable, there is some memory being created in your RAM or main memory where you can store this value. That's why it's called instantiation in some textbooks. It's just a fancy English word. So important thing that you have to notice here, just like data for a given data type, you have variables in a data type you can create, which creates locations in memory. A class has an object. I mentioned this in the previous live sessions also. Just a quick recap. Now let's build a class, right, called URL short URL. Again, here there are many concepts of object-oriented programming. I'll go step by step. Right now, our view is this. A class is basically a group of variables, right? Again, variables are called as attributes in object-oriented programming in Python, right? Different programming languages use different terms. Python calls these as attributes. Instead of calling functions, they call them methods, right? But it means the same thing, right? Into a single logical unit. Okay, so that's the goal here. Let me there are a couple of typos here, right? So a class is basically grouping all the variables or attributes and the functions or methods into a single logical unit. So what I do here is this. Suppose if I want to create a class called short URL, the way I do it is this. I say class. Again, this is a keyword in Python. Class short URL semicolon. Everything that is there with this indentation, anything which is there with this indentation of is within the class. Cool. Let me just explain some simple syntax. Again, if you already know object-oriented programming in Python, you may not benefit much from this because I'm starting from the very basics here. Okay. So first and foremost, okay, there is this, I'm again, within this, I'm creating a function called underscore init underscore. Now this is called as a constructor, right? I'll tell you how a constructor works. Just remember that the function which has underscore init stands for initialization. Underscore, this function in any class is called a constructor. It's a special purpose function. I'll explain you how a constructor works when I create an object. Just bear with me, right? Again, a constructor is not must, but it is always a good programming practice to have a constructor. Now, what is the purpose of a constructor? Look at this. In my short URL, effectively, I want to have a dictionary D. And I want to have two functions, right? Get short URL, get long URL. These are the two functions that I want, or two methods that I want. Again, let me start using this terminology. These are the two methods or functions. This is the variable or the attribute that I want. Now, the purpose of a constructor is I want to initialize all attributes that I want in this class. In this class, what attribute do I want? I want a dictionary D. So what do I do here? Again, any function that you have, the first parameter is called as self. I'll tell you what is self in a little while. Just bear with me. Because I'll have to connect this concept to a concept of an object so that everything fits together. Okay. I'll tell you what is a constructor when we create an object. Self also I'll explain you when we construct an object and how it works internally. right? So just remember that self base. Okay, so we'll go there. Just bear with me. Okay, I'll tell you what is self, what is constructor in a few minutes. Just bear with me. All that I'm saying here. So self basically means, okay, let me see. Okay, suppose this is my constructor. Okay, so okay, let's go here. Okay, let me also tell you the creation of an object. Okay, so if you think broadly, let's look at the high level, then we'll go step by step. So this function is called as a constructor. This is my get short URL. This is my function get short URL. I've changed it slightly, not much, right? Then I have the get long URL. If you notice, what do I want in my short URL? I want a dictionary D. I want the get short URL. I want the get long URL. These are the three parts that I want, but I've modified them slightly, right? I've modified them slightly. Now, if I want to create, suppose for example, I created this class. I told you just a while ago that a class has an object, just like the way a data type has a variable. Now, if I want to create a variable of this class, look at this. As soon as I define a class like this, nothing is created in memory. As soon as I create it, as long as there are no syntax errors, it doesn't give you any error. We are just defining what this class should look like. It has not created anything in memory. Now look at this. The moment I do this, I say s equals to short URL. Look at this. So the moment I say this is the syntax. S equals to short URL. Now what is happening? I am saying I want to create a variable, okay, or object. Instead of calling it a variable, we should call it object. So S is a variable of short URL data type, also short URL class, right? So short URL is the name of the class, right? Short URL is the name of the class. So what do I do now? By using this syntax, where I say S equals to short URL, look at this, I'm calling short URL as a function. I'm calling this function notation here. I'm using as if I'm calling a function called short URL. Now, as soon as this happens, what happens is in memory, okay, it creates in your RAM, it creates some space which I can access using this variable name S. And what is created in this memory? Look at this. The moment I run this, what is this? I'm creating an object, or I'm instantiating an object of class short URL. The moment I call this, what happens is this will go and run the constructor, right? So this will go and run the constructor. What is constructor here? Constructor is always defined as underscore underscore into underscore underscore. Now what happens here? Immediately, look at this. I said S equals to short URL. Now there is no function called short URL. There is a class called short URL. So what is this function that is going to execute? It is going to execute the constructor. Okay, it is going to go and execute the constructor. Now when it is executing the constructor, the self here, self basically means, self is a reference to the object that is calling it. Here self basically means S, because I'm calling this for the variable or the object S. Look at this, I'm calling this constructor. If you notice what is happening here, I've created a variable or an object called S, and I'm calling this constructor. When I call this constructor or any function, when I call any function here, as soon as I use this syntax, the constructor is called, the memory is allocated, right? When the constructor is called, the self here basically means the object that has called this function, right? So because the object or the variable name can change. Once I can say S equals to short URL, other time I can say S1 equals to short URL. So we don't know what is the object name or the variable name, right? So here self basically refers to whatever is the name of the object that is calling the constructor. Now in the constructor, what happened? Look at this. In the constructor, I'm saying self.d equals to dictionary. So this function, see, remember I said S equals to short URL. I just executed this line, right? The moment I executed this line, there is in my main memory or RAM, right? There is some memory created to store all of these, to store all the data that is assigned here, and I can reference this using S. Now what does it say? In the constructor it says self for this object. Self basically means for this object. For this object, create a dictionary called D, and the dictionary will be empty. Very simple. The dictionary is empty, right? So what happens is within this memory location, there is a dictionary that is created now. There is a dictionary that is created. Very interestingly, right? So that's what has happened till now, right? So I hope this is clear, right? So here is an object, here is a constructor. The moment you execute the constructor, so the moment you create an object using this syntax, the constructor is called, and whatever is there in the constructor is executed. Cool. Now, actually, if you think about it, there is a constructor that's running here also. Dict is also a class. If you notice, actually look at this syntax, right? How do you create a dictionary in Python? One way of creating it is this. You can say dict. This creates an empty dictionary. Now, what you are calling here is the dict is actually a class. Dict is actually a class in Python, and you are calling this class's constructor, right? Just wanted to connect those two dots for you. Now, once we are done that, we are not yet done. We are still getting started. If I want to know the data type of S, again, we know how to do it, right? You just print type S. Then what does it say? It says S is of type class, and what class is it? Underscore underscore main underscore underscore short URL. I know it is short URL, but what is this underscore underscore main underscore underscore? What does this mean? See, look at this. The data type of S is, I know that it is a class and the class name is short URL, but what does this underscore underscore main underscore underscore mean? What does this mean? Right? So again, I'll just explain that quickly. So this whole script by default in Python, any script you write which is not within another module, the underscore underscore main underscore underscore is the main module in which this program is actually being executed, right? So that's why you always see this. Again, imagine if short URL was defined in a completely different module. Again, if you remember import, we import modules using import, right, in Python. Suppose if I have import math, imagine if I have a class within math. Okay, so imagine if I have a class within math. Okay, or let's look at this, look at it like this. Suppose if I import numpy, okay, instead of math, numpy is better because we've seen a lot of examples. So let's assume I import numpy as np, right? Suppose if I create a variable a equals to np.ndArray, right? Suppose I create this. Now if I ask for the data type of a, it will say the data type of a is numpy.ndArray. We have already seen this in the previous live sessions. Why does it say this? Because ndArray is the name of the class and numpy is the module in which this ndArray exists, because we imported this module, right? So the default module, right, from which this whole code or script is invoked is called as a main module. If you don't have this in any other module, the default module is underscore underscore main underscore underscore, right? Very simple. Again, if you want to understand more about modules, I assume that some of you know modules. We'll try to cover modules also in the next live session. But if you want to understand more about modules, here is a very, very simple explanation of modules. Again, if I have to put it very simply, a module in Python is same as the code library. It's basically a file. A module is a file in which you can have a bunch of variables, right? You can have a bunch of functions and a bunch of classes, right? It's basic. When you say import math, there is actually a math.py somewhere, right, which has all the functions, variables, constants, classes that are part of math.py that you're using, right? So for example, let's look at this. I'll show you that. It's actually very simple to see. Math.py in Python. Okay, if you just Google search for it. Okay, where are these? Okay, so just go here. Okay, does it say math has, okay, so look at this. Math has, within the module called math, there is a function called ceil. There's a function called copy sign. There is a function called f absolute factorial blah 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 blah. But you can also find math. If you go to GitHub, right? Okay, look at this, Python skeletons. So here is an example of math.py. Okay, I hope, okay, I don't think, is this the actual official implementation? Looks like it has hundreds of lines of code. Again, you can look up the official implementation of math.py. Right? So you have all these functions, ceil, fabs, floor, all these functions which are part of the module math, right? So again, that's what modules are. Module is nothing but it's basically a Python file which has a bunch of variables, functions and classes defined. You can think of it like a code library. That's why I often use the term library and module interchangeably. Okay, sounds good. Very good. So now what do I have? Look at this. So I created a variable or a object called S of type short URL class. Cool, very good. So the moment I called this, look at this, the moment I created this variable, the constructor got executed and now I have a dictionary. Okay, the dictionary is empty, obviously. Now, if I want to call URL, if I want to, let's say, shorten a URL, look at this very importantly in the implementation of any function which is there within the class, the first parameter is always self. Look at this. In my get short URL, right, the first parameter is self. In my get long URL, the first parameter is always self. On the other hand, when we implemented a procedural based implementation, there is no self because there is no concept of an object here in a procedural implementation. In an object oriented implementation, because this get short URL and get long URL are within this class, right? Every method or function within the class takes self, or self basically is nothing but it's a reference to the object that is calling this. That's all it is, right? So simple, nothing fancy here. Okay, so now let's see how get short URL works. So for example, okay, so we have created this variable or object called s. We know its data type. If I just say s.short URL, what happens? Look at this. I just said s.short URL and I got an error. What error does it say? It says short URL object does not have attribute short URL. It says I could not find short URL with smaller s in the short URL object. Why is it so? Think about it. It's a very common error because the function name is called get short URL, not short URL, right? So very often a very common mistake is people create an object and they don't look at what function is there inside and it starts giving these errors. So whenever you get an error like this, go to the function, go to the class reference or the documentation as we have done in previous live sessions. Just go to the documentation and say, what is the function that is actually there here? Right? For example, if you look at NumPy, right? So NumPy ND array reference, just Google search for it. Okay, NumPy.ndArray. So if you go to the reference here, it says, okay, the class is the NumPy is the module, ndArray is the name of the class. And the structure that it is showing here is the constructor. The constructor takes a shape, the constructor takes a D type, all these variables. Now look at all the parameters that are there. These are the parameters to the constructor: shape, D type, buffer, offset, etc. Right? Again, look at all the attributes that are there. These are all the variables that are there. Look at all the attributes that are there, all the methods that are there. Now, if you get any error like this, where it says the attribute did not exist or the method does not exist, just go to the documentation and see if that method actually exists. These are all the methods that are there in ndArray, right? So these are all the attributes or variables. These are all the functions or methods. I'm using the Python terminology. Cool. Now we know that it should be actually get short URL. So how do I call this? I say s.getShortURL. Again, I need this object. Look at this. I need this object to call this function. So I say s.getShortURL AppliedAICourse. Okay, it will print this. So this is my short URL. Again, I say s.getShortURL get.AppliedAICourse. Get.AppliedCourse actually, sorry. Get.AppliedCourse. That's the name of our web page. I'm sorry. So you just type in this, you get a short URL again. It works, right? Cool. Now again, if I want to use the get long URL, I use the object dot. This is the syntax. Again, we are talking with respect to s. This s is the name of my object. S is the name of my object. So if I want to use if I want to call get short URL or get long URL, the most popular way is to actually use the object dot syntax, right? So I got my long URL, short URL. Now if I just give my short URL, my get long URL will get me the actual address. Now if I want to print, look at this. So what is happening here? I have in my RAM, there is some memory allocated which I can access using variable name s, right? Which is nothing but my object. And when I instantiated this object, or when I created this object, there was a dictionary D that was created. If I want to access this, can I access it? Yes. You can just say print s.d. Look at this. See, look at this. The s.getShortURL and s.getLongURL, right? When I say s.getShortURL, let's see what happens. I'll go through the code for you again, right? Now, when I say s.d, it will print whatever is there in the dictionary corresponding to s, right? So let's look at it. So the moment I said s.getShortURL, how does this work? How does the implementation change now? We know the implementation of the constructor. It is basically creating a dictionary. Next, when I say get short URL, look at this. The get short URL, I'm saying s.get short URL. Right? So the first parameter is always the object that is calling this function. Next, if you look at this code, all of them are just same as what we have discussed in the last session. Everything is the same. The only change that I've made here is I have said self.d here. That's the only change, except that this whole code is exactly the same code as we have discussed in the previous live session. Here I am saying this. So why am I saying self.d here? Again, to be very precise, what I'm saying here is if I call s.getShort URL, look at this. I called s.getShort URL with some long URL here. So what it means, what it does now is, so in my RAM, right, I have my s, which is pointing to this whole memory location in which there is a dictionary D. The moment I do this, look at this, when I say self.d, self basically means this object which is using which we are calling this function. So self, you can think of it as the object that is calling it s. So self.d is nothing but s.d, the intuitive way of thinking about it. So what it's doing is it is adding this short URL and long URL as keys and values in your dictionary D corresponding to your variable s, right, or your object s. That's important. Now the get long URL also, I've changed it very slightly. Look at this. The only change that I've done in the get long URL is, again, the first parameter is always self. Now when I say this, what happens? This is okay, sorry. Okay. So when I say this, what I always pass the first parameter as self. Again, short URL. Now the only change that I've done here is I've changed this line and this line. Instead of just saying D, I'm saying self.d. Because if I call s.getLong URL, if I call s.long URL with a short URL here, right, I want it to go and look for the dictionary which is there in s. And because I'm calling the get long URL using this variable or object s, self basically means that s. So this will basically be translated into s.d. This will also be translated into s.d. That's the logical way of thinking about it, right? That's the only change. Rest everything, the logic is exactly the same. Now you might say, why are we doing all of this? I'll come to that. Please bear with me. Just please bear with me. I'll explain you why we are doing all this complex stuff. I'll tell you from a software engineering perspective in a few minutes. First, let's understand the basics. Okay, cool. So I got all of this. Okay, so now I can say my s.d is this, right? I can access this s.d and I can add more things here. Look at this. My s.d is nothing but a dictionary. I can add this as the key and I can add this as the value if I want. So I can keep adding whatever I want into the dictionary. Again, remember that this dictionary D is there in the memory location that S has created, that is created for object S. But I can access this dictionary and use it like a regular dictionary, whatever way I want to use. Cool? Very simple. Now, this is how you take procedural code. Now you might say, why are we doing all of this? Please bear with me. Just 10 more minutes, I'll explain you that. Let me explain a few cases. So what have we done? We have taken a procedural program where you had a dictionary, you had two methods or functions, which is get short URL, get long URL. We have done all of this. Cool. We have translated this into a class, right? With a constructor, we understood what is self, we understood what is class, that this is that we have an attribute D, we have these methods and all of that, right? So all that is cool. Now let's go ahead and learn a couple of other things now, right? So for example, imagine, again, there are a lot of details and boundary cases. Imagine if I want to create an empty class. Look at this. Is this allowed in Python? Yes, it's allowed. I can create a class. Again, my class name here is empty class. I'm creating a class called empty class. Again, it is just always a good programming practice to always name your classes using camel case. Camel case basically means it should be capital. Every word's first letter should be capital. That's a good programming habit, right? So that's a good programming habit in general, right? So again, this is basically good programming practices. So imagine if I just execute this, okay? So what did I create here? I created a class called empty class. If I don't want to write anything inside this, what can I do? I can just use this keyword called pass. When I say pass, what it means is there is nothing here. The way you write a class is you write class, the class name that you want, colon, everything that you want within this class, of course, with indentation. If you don't want to have anything, if you want your class to be empty, you can just use this keyword pass. Now I can always say E equals to empty class. So what does this do now? What does this do now? Okay, there are a couple of interesting things. Okay, I'll answer those questions. The moment I call this, there is no constructor here, right? So what is it executing? That's a good question. I'll explain that in a little while. When we learn inheritance, I'll explain that. Right? So there is no constructor here. What is it doing? All that it's doing here is, okay, I'll come to that when we learn inheritance in more detail. So this is basically creating some memory location for E, right? It's basically creating some memory location which will be pointed by E. That's all it's doing. That's all it's doing intuitively, right? So I can say what is the type of E? It says E is a class which is in the module, main module, and its name is empty class, okay, because I called it empty class. Now your quick question should be, when I call this, it is calling a constructor, but I don't see a constructor here. What's happening here? We'll learn that. Just bear with me. Again, very importantly, there are lots of internals, there are lots of boundary cases on how to create classes, what works, all the complex cases, which are these boundary cases and internals is very important if you are a software development engineer. And if you want, again, we will not be able to cover that in just a couple of live sessions. So I'm going to focus more on applied aspects in the context of machine learning and AI, right? But if you want to learn more about it, there's a beautiful documentation and tutorial for Python 3. Again, I've made a lot of these notes based on this itself. This is a very nice documentation. After you see this live session, you will be able to go through this documentation and understand more details. This is not exactly a documentation, it's a tutorial on how classes themselves work, right? So I will not be going and handling all the internals, all the boundary cases, how are objects stored internally. I will not be going into the design of interpreters for Python. That's a huge internals topic, right? That is beyond the scope of these discussions. Our objective is to help you become better programmers from an applied sense in the context of AI and machine learning, right? So I'm limiting the scope here. Otherwise, we can just spend tens or even 50 live sessions just on the internals of Python. There is tons of beautiful internals. Again, these are stuff that I learned over the years. It's nothing that I learned overnight. Okay, cool. Now here comes some more cases. Let's look at some more interesting cases, right? So imagine if I do this. Okay. So there is a concept called as class variables. So let me explain what is a class variable. Okay, so we created a class called short URL earlier. Now we are creating something called as short URL1. Okay, I don't want to name the same class. So this is a different class that I'm creating. The code, everything is the same except for this single line. So in this single line, what I'm storing here is I'm creating a variable which stores this string. Right? Look at this. This variable is outside all of my functions. It's outside all of my functions, right? So this is called URL prefix. Now this URL prefix, which has this string, look at this. This URL prefix is nothing but this thing. Such a variable is called a class variable. Now let's see how class variables behave. Everything else is the same, right? Now let's see how class variables behave and why do we need them. Suppose if I say S1 equals to short URL 1, okay? Now, okay, I'm doing some short URL. Look at this. Again, there is one more change that I've done. I forgot to mention. Sorry. There is one more change that I've done. Okay. So this URL prefix, I've actually used it in my code here. Okay. So there is one more change. Where is this? Okay. So I'm saying self.url prefix plus short URL. I'm using it only in this line. So there are two lines of code change. This line and this above line. So if you look at the previous class definition, let's look at the previous. I just had a constant string here. Instead of keeping the string constant, I've created a variable to store this value. Now what happens here is this. Suppose, okay, let's see what are class variables and why are they important. Suppose, imagine if I create a variable S1 equals to short URL1, right? Short URL1. Suppose I create this variable, right? I also create S2 equals to short URL1, because the class name is short URL1, right? So what am I creating here? I'm creating two objects. or two variables of type short URL1. Now both these variables, look at this, both these variables will have the same URL prefix value. So if I say s1.url prefix or s2.url prefix, it will print this string only. Because whatever variables that you declare outside of these classes, they are called class variables, and the same variable is shared by all objects. So if you want to have a constant string like this, if you want to have a string which is constant, which is used by all the objects of the class, like if I say s1.url prefix, it will print this, s2.url prefix also it will print this, right? So that's because both these variables are of the same class, and this URL prefix is a class variable shared by all objects, right? So that's the concept here. Now let's see. Suppose I have s1 equals to short URL1. I use get short URL. I did all of that. Now if I print s1.d, okay, what is my d? Again, remember, the dictionary d is different. So when I create two variables, let's assume I create variable s1. Actually in my code I say s1a. So I have, let's assume, two variables s1 and s1a. Both of them are of the type short URL1. Their class is short URL1. When I create the constructor for this, look at this. When I create the constructor, in the constructor code, what happens? I allocate some memory and I create a dictionary for this. Similarly, when I create s1a using short URL1, what am I doing here? Again, I'm creating some space and I'm creating dictionary d here, right? So this dictionary is different from this dictionary. Remember, this dictionary is different from this dictionary. So s1, so I created s1 here. I created some URL shortening, and if I print s1.d, what do I get? I get s1.ds. Look at this. I get s1.ds. I get s1.ds, whatever is there in the dictionary. And if I print s1.url prefix, I get URL short URL.com. Now I create another variable s1a. Okay. So this whole dictionary is there in D here. Now s1a equals to short URL1. Now this dictionary is empty. Now if I say s1a.url prefix, remember URL prefix is a class variable. So both object s1 and object s1a will print the same thing. So s1 and s1a share the same value for URL prefix, because URL prefix is a property of the class, right? It is a value that is constant for all objects of the class. Unlike this dictionary, look at this. This dictionary for s1 is different from the dictionary for s1a. For example, if you print s1a.d, you get an empty dictionary because I did not add anything to the dictionary. But if you print s1a.url prefix or s1.url prefix, you get the same string. That's the important difference. So those are called as class variables, right? It's useful sometimes. So what is the purpose of class URLs? If I want something to be constant, if I want to have a constant value like this, for which is shared by all the variables, whether you create a variable s1 or you create a variable s1a, all of them I want to have this variable which is URL prefix to be constant. If I want that, I create a class variable for it. That's the purpose of it. Cool? Simple till now? Okay. So very importantly, this happens to me a lot and it could happen to many of you. I actually learned object-oriented programming in C++ and Java and used it extensively for many years, right? So what happens even now, even today, okay, is when I write code in Python, I get confused with the syntax and the internals, because the way C++ objects and classes work is different from how Java works, which is slightly different from how Python works. Each of these programming languages, while all of them follow the properties of object-oriented programming, all of them have their differences. So today while writing some of this, I said, okay, S equals to new, I actually did this, to be honest with you. I actually wrote Java or a C++ like syntax, right? I actually wrote a Java or C++, then I said, okay, wow, this is Python, this is not Java, right? So if you already know object-oriented programming in other languages, it's very easy to get confused with syntax and internals. So please be aware. Of course, your interpreter will start giving you errors and you'll learn from it, right? So now comes another thing. Okay, so now let's look at this. What if, okay, let's learn another concept called as private members. Okay, what are private members now? Okay, this is an interesting concept. I think especially people who have learned C++, right? C++ has this keyword called public and private. The same concept does not does not work exactly in Python. So those of you who know C++, think of this is sort of like the private in C++, but not exactly, right? So let me explain what is a private member and why is it useful. So imagine again, now I'm creating a new class called shortURL2. I'm just creating new classes, same code, very same code, except a small thing. Okay, very small change. Now, if you want to have something, okay, look at this. This is a class variable. Remember, this is my constructor. This is my method. This is a class variable. I'm creating a class variable called test. All right. Now, additionally, what I'm doing here is I'm creating another variable here, which is underscore URL prefix. Variables that are created like this with 2 underscores are called as private members. Right? What is a private member? Okay, suppose imagine logically, you don't want to be able to access this string from any other function outside of this class, which means you should be able to access this only from the constructor, the get short URL and the get long URL. Those are the 3 methods that you have. So if you want any variable like this to be only accessible to functions within the class, such a variable is often referred to as a private member, right? It could be a variable or it could even be a function, right? So again, we use the term member when we have to say an attribute or a method. Okay, a member basically means an attribute or a method. Now, again, so look at this. I'll show you an example, right? So now what have I done here? So this is my class variable. We know what is a class variable, right? A class variable basically means this is constant for all objects of the class. This is a private variable or a private member or a private attribute. Okay, the Python calls these as attributes instead of variables. Now this I can use it within this function, and all the functions in the class. So the change that I have done here is I've also used URL prefix here. Look at this, the underscore URL prefix I have also used here. That's it, nowhere else. Instead of URL prefix, I changed it. Now let's see how this works. How do private members actually work? Suppose if you don't want this variable or attribute or this member to be accessible from outside this class. So let's write some simple code. Suppose I say s2 equals to shortURL2. If I want to print s2.class variable, remember, look at my class variable. My class variable takes a value test, right? So this is cool. My class variable takes a value test, right? The interesting part here is if I print s2.class variable, it will print test. Look at this, it prints test. If I print this s2.class variable, it prints test. Why is it so? The class variable is storing test here. It is storing test. And if I create another variable s2a also, it will also print. If I create another variable called s2a of class shortURL2, and if I print s2a.class variable, it will also print test, right? But remember that I can access class variable attribute or this variable from outside the class. This line of code, look at this, this line of code is outside the class definition. It's outside the class definition, right? But still I'm able to access it using this object. Now the moment I try to do this, especially in Python 3, if I say s2 dot underscore URL prefix, the moment I try to do that, it gives me an attribute error. So this line prints successfully, this line gives me this error. It says shortURL2 object has no attribute called underscore URL prefix. Again, this is slightly implementation dependent. So technically, if you read the documentation in Python, it says there is no concept called as private variables, but it is implementation dependent slightly. The rule is any variable name that starts with double underscore or any function name, anything that you have like this, you should treat it as a variable or a member that you should only be accessing from functions within the same class. You should not access it from outside the class like this. You should not access it. That's the simple rule of thumb. These are called as private members. Again, I'm just introducing some basic concepts. Now, okay. Now all this is cool. Okay. So a couple of theory concepts. I just wanted to touch upon them so that you know what these terms mean. Again, I've taken these definitions from Wikipedia. So there are a couple of things that every object-oriented programming language should have. Right? First concept is called abstraction. The second concept is called as encapsulation. Now again, I've taken and I've used Wikipedia's definitions here just to be clear, right? So I've also given other resources for it. In general, abstraction basically means, look at this, again, it's a very nice definition. Each significant piece of functionality in a program should be implemented in just one place in the source code. That's the idea here, right? So abstraction basically means, look at this. Again, abstraction and encapsulation are slightly confusing. Abstraction basically means it's always good, anything that you want to represent, right? The main, again, this is a very nice representation. This statement I've taken from Wikipedia. The main goal is to handle again, I like this definition also. The main goal of abstraction is to handle complexity by hiding unnecessary details to the user. For example, let me give you an example, right? So we talked about ND array, right? We used NumPy's ND array. Do you know how ND array stores things internally? Again, we discussed this in the previous live session, that it stores it using a chunk of memory, using C++ representation in the previous live session, right? But as a user of ND array, you don't have to know how ND array works internally, right? So all that is abstracted away. All that is abstracted away. You don't have to be an expert in low-level representation of numbers, arrays, matrices, tensors. You don't have to worry about all that. So you as a user can just say import numpy and numpy.ndarray, and numpy.ndarray is a bunch of functions. You can just use all of them without worrying about the implementation details. So that's what abstraction basically is. Abstraction basically is all of the things that the end user, like you are a user, right? As a programmer, by end user I mean you are the user. When you say import numpy, right? When you say import numpy as np, and when you say np.ndarray, right? So suppose you create an ND array, so and then you do some operations on this numpy ND array. So you are the user here. You as a programmer are the user here. The person who implemented ND array is abstracting away all the complexity away from you. So you as the user or the programmer need not worry about how this is implemented. This makes life easy, because as a programmer, if I just know a bunch of libraries, I don't have to worry about how things are implemented internally, because this ND array implementation is fairly non-trivial, right? Lot of operations on a lot of functionality and methods on ND array, the implementations are fairly complex. But as a user, as a programmer who is using NumPy ND array, I don't have to know all of that. That's what abstraction is. Abstraction basically means the internal details of how this class is implemented, all that I don't care about. I only care about what methods are there, what attributes are there, and how I can use them. And what do they do? Right? That's what abstraction is, right? Again, abstraction is not a concept that is limited only to object-oriented programming. Abstraction as a concept is there in C libraries also. Any libraries that you use in any programming language. So that's what abstraction as a principle is central to computer programming, right? So any functionality, right? Whether it is creating a C library. In C, you used to have this math.h, a header file that you import. And if you have ever written C program, you import math.h and you call a bunch of functions, which you can access via the math.h. That is also a form of abstraction. So class is one type of abstraction, while abstraction as a concept is very general. Any library, any pre-built library that you as a programmer use is a form of abstraction, right? That's one. The second concept, again, I've just pointed you to some nice links here. Again, I prefer this definition, which I've taken from Stackify. Very nice definition. Next concept is called as encapsulation, right? This is something which is more core to object-oriented programming. Now, you might say, okay, again, I've taken the definition of encapsulation from Wikipedia, put the link here. In most object-oriented program, again, remember, abstraction is there even in non-object-oriented programming languages. Encapsulation is mostly in the context of object-oriented programming. Clear, Wikipedia says that, right? mostly in the context of oriented programming, but also others, right? Encapsulation refers to one of these two. It could be both, a combination of both, or just one of them. It means, encapsulation basically means it is restricting direct access to some of object's components. Look at our private members, right? Look at this. Our private members that we just discussed right now, our private members, right? You cannot access them, right, from outside the class. So this is a way, it's a mechanism. It's a mechanism as part of the programming language to restricting direct access to some of object's components like private members, right? Python has this. Similarly, another concept in encapsulation is a language constructs that facilitates bundling of data with the methods operating on the data. This is what we have seen, right? Our short URL class that we have seen is, I have data, which is my dictionary, and I have these two functions, get long URL and get short URL, right? These are functions which are operating on this data. That's why I've put all of them into one entity. That's what is called as encapsulation. Cool. Again, these are technical terms that you encounter in textbooks, but I want to connect it to the example. That's why I've used Wikipedia definitions. Now here comes a very good example. Now you might be wondering, why the heck are we complicating things? Now let me take you an example from software design. Okay. Suppose, okay, this is where till now whatever we've discussed is just blunt theory. Okay, here is where the true applied stuff comes. Suppose I have implemented the short URL. Okay, so we have done short URL 1, short URL 2. Let's say I've created an implementation, let's call it short URL final. This is a class that I implemented. Okay, there is some functionality in this. You don't worry about it, right? So this is something that I implemented, right? Suppose you are another programmer. You say, hey, I really like this implementation, right? I want to now modify it. I want to modify it slightly. I want to modify this because this implementation, I know that it has a dictionary D, right? Internally, it has a bunch of other attributes and a bunch of other methods, right? So in the documentation, you just give all the attributes, the data types of the attributes and all the methods. That's what you just give. The implementation, the user or the other programmer. So let's assume this is programmer 1, this is programmer 2. Programmer 2 says, oh, hey, this short URL final is very good, but I want to modify it slightly because I want to use it in a different context, right? I want to modify it. Now he might say, how should I modify it? Again, depending on the application, he could come to us and say, hey, I am a software engineer. I want to design another thing called my URL shortener. I want to design my URL shortener. Given that someone else already implemented short URL final with some changes. What changes do I want to do? Two things. First, I want the get short URL to have both alphabets and numbers. If you remember in our implementation yesterday, which is also the code that I've shown you yesterday, our short URL was only generating, how was it generating? Look at this. How was it generating? It would say shorturl.com and it would only generate 6 to 10 alphabets only, no numbers in this. Now I want, like, this is already there. Let's assume somebody gave me this. This is implemented by programmer 1. Now programmer 2 comes and says, I really like this, but I want to modify it slightly. How do I want to modify? I want to have the short URL to contain both alphabets and numbers, not just alphabets. That's the first change he wants to do. The second change he wants to do is, I want to change the URL prefix itself. Okay, so the URL prefix that is there here, the URL prefix, which is one of the attributes, by the way. The URL prefix attribute, that is one of the attributes here, is, let's say, short URL. I don't want to use short URL because my website is called my URL shortener. So I want to change the URL prefix to my short URL. Simple. Now let's see how this whole short URL final is there internally. Look at this. Look at the application is very important. Somebody has written this. Now as programmer 2, I want to modify this. I want to modify two aspects in this. Right? First, I want to have both alphabets plus numbers in my get short URL, and I want my URL prefix to be my URL shortener instead of shorturl.com. Right? That's what I want. Now first let's freeze the URL. So in my, let's assume programmer 1 implemented short URL final as follows. Okay, look at this. URL prefix is not a private member. It is a public member, which means I can access this from outside the class also, because there is no 2 underscores here, right? Rest everything is the same. There is a constructor here, there is a get short URL, and there is a get long URL. Cool, all this is cool. Now I want to define my short URL. Look at this. I want to define my short URL, but I don't want to implement everything that is here, because this implementation is pretty good. I really like this implementation. I just want to modify a couple of things. How do I do it now? Now let's go. Again, this is very interesting. Here comes the concept of inheritance. So inheritance is one of the biggest applications why you should use object-oriented programming as a machine learning engineer, right? So inheritance is the crux. Let me explain you how inheritance works. Okay, I'll introduce you to some terminology also, and I'll give you some reference links to learn more. So our objective is, let's define my URL shortener class based on short URL final. We have already seen how this works. So what do? I say class my URL shortener, and within this braces I'm saying short URL final. So what this means is that I want to build my URL shortener on top of short URL final. And how do I build it? I'll explain that. So this is often referred to as the base class. This is often referred to as the derived class in inheritance. This concept where I'm saying I already have short URL final. From short URL final, I'm designing my URL shortener, right? I want to have all the interesting functionality that it has, but I want to modify a couple of things, right? So to say that I want to inherit all the important all the functionality in this. Look at this. First, I want to inherit all the functionality in this. So that's why this is called as base class. This is called as derived class. And how do you tell the Python interpreter that? You say this is my base class. In your function, look at it, in your class definition. Sorry, when you're defining your whole class, you say my class name is my URL shortener, and it is a child, or it is a derived class from short URL final base class. Now when you do this, now let's see what happens. Okay, remember your short URL final has 3 things. It has a URL prefix, it has a dictionary internally, it has a get short URL, it has a get long URL. Those are the 4 things that it has. Now I am saying here that URL prefix is my short URL. So what happens here is this. This is very interesting. Okay, so this is very interesting. So I have my short URL final, right? So it has an implementation. What all does it have? Look at this. What all does it have? It has a URL prefix, right? It has dictionary D. It has get short URL, right? It has get long URL. These are the 4 functionality it has. Now I have derived from this. From this I have derived. So this is my base class, and I have derived from this another class. Let's call that class as my URL shortener, right? My URL shortener. Now in this, when I'm defining this class, if I say URL prefix equals to, look at this, if I say URL prefix equals to something. Now what happens here is, the moment I inherited this class, see I inherited, because of the way I've written my code, this is my base class and this is my derived class, right? Which means I have inherited everything that is there in this class. But here what am I doing? I'm redefining my URL prefix, which means there is already a URL prefix here. So when I inherit it, what happens? The same URL prefix comes into this also. But now what am I doing here? I'm overwriting it. I'm saying I don't want to use this URL prefix. I want to have a different URL prefix for this class, right? So what's happening here effectively is, what's happening here is, by writing this line, I'm saying I don't want to use this URL prefix that is there for in the base class. I want to redefine it to whatever I want. Again, that was one of our tasks, right? What was our problem? What was a real problem that we wanted to solve? We wanted to create a my URL shortener with my custom URL prefix and a different implementation of get short URL. That's what I wanted, isn't it? Cool. So what do I do now? Yes. So I changed this. Now remember, in this changes that I wanted to do, I didn't want to change the get long URL. Look at this. In this change, look at this. So I overwrote this. So I overwrote it. So now in my short URL, my URL shortener, my URL prefix will be this. Now I also want, see, my D hasn't changed. My D stays the same because I haven't changed the constructor or anything. I haven't changed the constructor. Okay. I want to change the get short URL also. I want to change this. I don't want to change this. Look at all the stuff that you want to change, all the stuff that you don't want to change. Again, this dictionary is created in the constructor. So if you notice the program that we have written here, where is this? Yes. So my short URL, my URL shortener is the derived class from short URL final, and I only want to change URL prefix and get short URL. If you notice in this class definition, when I'm defining this class, look at this. This is the whole class, right? This is how I'm defining this whole class. I did not overwrite the init. Right? This is a constructor, right? I did not overwrite it, which means I'm just reusing whatever is the, again, there is one more function here that I forgot to mention, sorry. There is also initializer, right? There is also a constructor. I don't want to modify it. I want to use the same constructor because in the constructor I'm creating this data structure D or dictionary D, right? I don't want to touch the long URL. That's why if you look at this implementation, I'm only changing URL prefix and I'm changing the get short URL. So this is what is called as overriding an inheritance. What does it mean? It means overriding. Basically, whatever I want to change, I'm going to overwrite it. Right? I'm going to overwrite and override the whole thing. Whatever I don't want to change, I will leave it as is. Now let's look at a very simple example, right? So, okay, first and foremost, I've changed this. Cool. I also want to change my get short URL. How do I want to change it? Again, we have seen this snippet of code yesterday, right? When we saw the implementation of this. Yesterday we said the characters from which I'm going to create the short URL using this. Again, I explained the join, all of this I explained in the previous live session. So in the previous code, in the short URL final code, if you see the short URL final code, look at this. In the short URL final code, the characters from which the URL shortener is generated is only ASCII lowercase, right? In here, I'm overwriting the function. The implementation, I just copied the same implementation. Nothing changes much. I've just overwritten and I said the characters from which I want to construct, because the characters from which I want to construct the suffix, right? Basically the URL shortener, I want to use both lowercase and digits. Again, this is the only change. Using the single line change, I'm saying the get short URL that is part of my URL shortener will create URLs which has both lowercase and digits. Rest everything I'm not overriding. Again, the fun thing here is, I know, look at this. This is already implemented by a programmer P1. Look at this, the whole thing, short URL final is implemented by programmer P1. I as a programmer P2 want to have most of this functionality. I only wanted to change two aspects of it. And only the aspects that I want to change, I changed. Rest everything I kept it as is. So as a programmer, if I want to modify a functionality of a data structure or any class that is created in some library, suppose NumPy ND array. Suppose I have class NumPy ND array, right? Suppose I like everything in it. There is one function or one method that I want to change. What do? I create a new class called myNdArray. Right? I create a new class called myNdArray and I'll simply inherit NdArray, and whatever new functionality I want to add, I'll add it. Rest everything I'll keep it as is. Right? Because all the beautiful stuff I want to reuse. So what is it creating? It is helping you reuse the code. This is one form of reusing, right? So again, this simplifies the code when you write extremely large complex code. Now let's see some examples, right? So I say m1 equals to my URL shortener. Now the question here is, I did not define the constructor here. Look at this, I did not define the constructor here. So which constructor is running? Look at this, in my URL shortener, I did not create a constructor. So which constructor is running? because we have inherited, look at this, because my URL shortener is inherited from short URL final, its constructor is also inherited here. So what is running here is basically the base classes constructor is running, right? So what is running actually is this snippet of code. What is actually running is this snippet, because the short URL final is the parent or the base class to my URL shortener, right? So this is important. Now if I say print m1.d, look at this. See, in my URL shortener, remember that m1 is an object of type my URL shortener. Nowhere did I initialize my dictionary D. But since it is inheriting from short URL final, this D that we are talking about is the D that is there in short URL final. And the D is initialized to an empty dictionary by the constructor. So as soon as this line got executed, the base class constructor is executed, right? And if I can print it, cool. Now look at this. Now when I say m1.getURL shortener, I say amazon.com, it gives me a URL shortener. Because when I say get short URL, which short URL does it call? Always. So look at this. I have m1, which is a variable. Look at this. I have m1, which is a variable of type my short URL. So when I say m1.getShortURL, first it goes to this class and it says, is there an implementation of getShortURL here? If there is an implementation, it will go execute this, right? So what's happening right now is it went to, so the getShortURL it is executing is the getShortURL that is there in this class, that is there in my URL shortener, right? It's actually executing this code. In this code, we know that the random string that it creates is both lowercase and uppercase digits. Sorry, lowercase digits. Sorry, it's both lowercase ASCII and digits, right? So that's why if you notice here, you get 2, 9, 3, all of them also. So which code is it running? It is running my URL shorteners get short URL. Now comes the fun part. Okay. Now if I say, okay, oh, I forgot to put it. Sorry. Okay. Suppose imagine if I run. Okay. Suppose if I say, if I wrote this line, m1.getLongURL. Suppose if I called this function with some URL, which function will it execute? Remember, m1 is of class my URL shortener. My URL shortener. Now in this class, I have not overridden the getLongURL. If you look at the implementation here, in this my URL shortener, I did not override the getLongURL. I did not implement it. So what happens? It will go to the parent class, because everything that is there in the parent class was inherited into the child class. I did not modify it. So what does it run actually now? Again, remember that my short URL is a derived class from short URL final. Now the short URL final had this function called getLongURL. So what it is executing is this. So whenever you are trying to execute this, it always goes to this object is of type my URL shortener. First it will check in this class definition if this function exists. If it doesn't exist, it will go to its parent. Till the time it finds this, it will keep going. Again, that's the simplest form of inheritance. There are more complexities here, but I'm just covering the base cases. We'll cover the complex cases little later, either today or tomorrow based on the time. Okay. Now let's look at one more example, right? So we've seen again, this is a real world example. In the real world, inheritance is extremely useful. First of all, there are two parts, right? The concept of a class. The concept of a class is useful because all the data structures and data types along with the functions that you want to operate on it are all grouped together in one logical entity, right? So that's why having a concept of a class and object is very useful, number one, right? Number two, again, understanding why we need it is extremely important. I can't emphasize this. Now, inheritance is a cool way to extend existing classes. It is an easy way to extend or to re-implement existing functionality, right? If I want to reuse everything that is there and modify only small pieces of it, inheritance is an extremely useful thing. Again, this is extensively used in most libraries that you use in Python. Okay, cool. Sounds good. Now let's go. Let's take again. I've taken an example. Again, this is a toy example, but I also wanted to show you a toy example. Okay. Again, some toy examples are good to understand the internals. Again, the example that I've shown till now is a very real world example. Let's look at a simple toy example. I've again taken it from overiq.com. Very nice examples they have. Let's look at this. Let's walk through this code snippet, right? So I have import math. Okay, so before we go in, let me see. We have a lot of stuff to cover. So let me do one thing. I'll go into the comment section. I'll go into the chat window, answer a few questions, and then come back to this, right? So just give me a couple of minutes. I want to take a quick water break. I'll take a water break, try to answer a few questions. Please leave your questions there. I'll try to answer a few questions. Again, I'll not be able to answer deep questions about the internals of object-oriented programming in Python, because that I'll have to show many more. Any questions related to things that we've just discussed right now? What we've discussed is, why do we need classes? How do we do classes in Python? Why do we need inheritance? And how do we do inheritance? I'll show you more toy examples and real world examples also. There is a lot more stuff to cover. Of course, we'll not be able to finish in one live session. So we'll use tomorrow's live session also. Okay. Oh, why do we need? Yeah, I'm happy. Some of you are already answering others' question. Thank you, folks. Thank you very much. So I'm happy that you guys are answering others' questions. Thank you very much. Okay. So what if? Okay, this is good. Good. So you can, again, there is something. So what if you have both base and derived class constructors? You can use them. Again, there is something called super keyword. I'll explain you that in the coming sections. That's a case that I handle. Somebody asked, what is the need of an empty class? There are some uses to empty classes also. I think I can show you that with an example. Okay, let me show you that example. There is this, again, those of you who know C structures will appreciate it. Where is it? Odds, blah, blah, blah. Okay, look at this. Look at this. Okay, this is a very, again, I'm just using the tutorial from Python documentation that I've pointed to. So look at this. Okay, so if you have an empty class, okay, so it's called odds and, so in this section, right? So again, this is from the python.org, Python version 3 tutorials. Okay, somebody asked, what is the purpose of having this? So some of you who have studied C has this concept called structures. Right? A structure basically in C is basically if you have a bunch of related things. For example, imagine if you have an employee, standard toy example, right? If you have an employee has name, department and salary. Suppose if you want to create C-like structures, again, I don't think many of you know Pascal. Pascal also has this concept called as record. I learned Pascal when I was learning something called as principles of programming language, where a lot of programming language concepts are covered from the viewpoint of many programming languages, right? But anyway, I'm not an expert in Pascal. I do know C fairly well, right? In C, there is this concept called structures. A structure basically has only attributes and no functions. Only attributes. If you want to create something like a C structure using Python, right? You can actually use it like this. You say class employee pass. So what it's creating is just an employee without any objects, without any attributes, without any methods, nothing. So you can say John equals to employee. Now you can create whatever fields you want now. Again, this is, I mean, I don't even know why they created this concept, but anyway, so this is one of the applications of empty classes. Look at this. So John equals to employee. John.name is John Doe. I can add whatever attributes I want. And now what happens? John is like a structure which is storing 3 properties of this employee named John with the full name, department, salary, etc. So one of the applications that I know of is to create a C-like structures. Again, if you don't know C, don't worry about it. Okay, this is one of the applications that is also given in the tutorial for Python for object-oriented programming. Again, somebody asked, why are we using empty classes in the real world? Yes, here is an example, right? You want to create structures, right? Suppose imagine on this employee, I don't want to create any functions or methods. I don't want to create any functions or methods. I just want to have variables. Of course, I could have created a class also. What I could have done is I could have created a class, right? And I could have said, okay, I could have created a, what do you call it? I could have created a constructor, right? Within the constructor, I could have had name, department, salary, etc. So there is only a constructor. There are no other functions. I could have done that way also. Again, so this is one of the applications that I know of, right? So one of the stuff that I know of. Again, it's not widely used. There are a lot of boundary cases in programming languages, right? So I consider this sort of like a boundary case, sort of like a boundary case within the programming language. Lot of these boundary cases are seldom used. They're not often used. They're very rarely used in actual design of libraries or in usage. I have never used this in my life. I know that something like this is possible, but I've never used it. To the best of my knowledge, if I recall, I've never reviewed code, Python code, which uses this, to the best of my recollection. Again, I've read thousands of lines of code and reviewed thousands of lines of code. I don't think I have ever seen an implementation like this to the best of my recollection, right? So it's very rarely used. So, so what if you don't have self? Things will fail, dude. So let me show you. That's a good question. What if we don't have self? Okay. So let's actually write something, right? Insert cell above. Let's just create a simple class, no? So that's a good question. So class A, let's just create. Again, for many of your questions, my suggestion, this is what, again, I don't remember all the rules of Python by heart. Whenever I have a doubt, this is what I do. I just implement it using a simple toy example and figure it out. Again, why do I do that? Of course, I can read the whole documentation internally. Again, I'm not, to be very frank with you, while I've used Python, I'm not the expert in Python. What do I mean I'm not the expert in Python? I mean, I don't know all the internal implementation of Python. I know some of them, but I've seen programmers, I've worked with fairly senior engineers in my teams who know the internal inside out of Python. They've actually literally ripped open the Python internals and read thousands of lines of code. So as compared to them, I am nowhere there. I've used Python extensively. I know some of the cases, I know some of the implementation details, I know how the interpreter works in some cases, but not all the cases. So whenever I have a question like this, I've been doing this ever since I learned, whenever I learn a new programming language also I do this. I learned Scala, beautiful functional programming language. I would try all this. So somebody said, okay, the question here was, what if there is no self? So let's assume I create, let's write a function, right? So def f, okay, let's write a function f. So let's assume this function takes this function takes I. Okay, so let's write print I. Let's assume that's it. Very simple, right? So this is a class A, which has a member function f, which takes I as a variable. Remember, I've not written self here. I'm just printing I. Okay, so now I create, I was about to write Java syntax. Okay, so, now you might wonder which constructor is running. I'll tell you that in the coming sections. There is something called as an object class, etc. I'll come there. So I say A equals to A. So lowercase a is my variable name. This is my class name. So if I say a dot f and 10, okay, let's see what happens now. So print. Okay, one second. So instead of doing this, okay, I can just say a dot f, right? Anyway, the print is anyway there. So I don't have to do that. Okay. So if I execute this, what happens? Look at this. See, what did we do? Again, this is a question that somebody asked, right? What happens if there is no self? Again, when you're in any such doubt, write a simple snippet of code, 5 lines of code. See, I should have given self here. I should have given self. I told you, right? The first variable is always self. If I don't have self, so this line executed successfully. What did it create? It created some memory location where I have a. Cool, all that is cool. Now I'm saying a dot f and I'm passing 10 to it. So the moment it passes this, look at this. In this line, there is an error. What is the error? It's a type error. Read the error carefully. It says f takes one positional argument, but 2 were given. So all that it's saying here is there is some mistake in the arguments. That's what it's literally telling you. It's literally telling you that there is some error in the arguments. Now what if I change this slightly? What if I put self comma this? Will this work now? Yes, it works. So if you don't have self, it will start creating these number of argument errors. Very simple example. Again, whenever I have a doubt in any concept, this is how I try to fix these doubts, right? So again, Python doesn't call them as pointers, Python calls them as references, right? Not point. Again, it's just again, Java also calls, again, I come from the C++ world. They have a concept called as pointers. Java and Python call them as references, right? So again, it's a language specific internal implementation. But if you want to think about it, they're very similar. Okay, so this is good. If we have two objects of the same name, will they be equal? Try it, let's try it. Again, I know the answer, but I want to try it for you, right? So suppose if I say A equals, again, any question you have, it's just 5 lines of code like this. Okay, so A equals to A. Oh, so if you do this, okay, so you're creating two variables of the same name. Okay, what happens now? It's executed. So now let's do one thing. Let's modify it slightly, no? So let's say okay, so let's create a constructor. Okay, let's create a constructor self and I. So then what we do here is we say I equals to or let's put some variable, right? Some var equals to I. Okay, so let's see what happens. And I'm just ignoring this. Okay, so what am I doing here? I just modified my class definition. I created a class A, wherein in the constructor I take I, and I'm creating this variable with this. Now let's see what happens. Okay, so a print. Okay, print A. So I'll have to change this also, no? So now what happens? I have 10 here. I have 20 here. Let's just say. So if I say print A dot, let's write this print dot A dot var. Control X. Let's see what this will do. Again, it's just simple 2 lines code. Sometimes that will help you. Okay. A dot var. Sorry. What is happening here? Var equals to D. Okay, so var is there within this. Okay, one second. So def print var. Just give me a second. Self print self dot var. Okay, so just sorry, my mistake. So if I just call this, okay, and if I just call print var a dot print var, yeah, I should say a dot print var because it doesn't know what it is. A dot print var. Okay, so now this will work. Control C. Again, I'm just constructing a simple toy example. What am I doing here? I'm creating a variable for the object. I should say self dot. Okay, self dot var equals to I, and I'm printing self dot var. Cool. So let's see what happens. Okay, look at this. Now A is my first variable. Look at this. So now we can also print the address of A and things like that, right? So look at this. This A, I'm creating an object here, right? And I'm calling print var. Now what is it printing? It is printing the 10 that is there. Now this A is overriding the previous A now, right? Obviously, right? If in Python in general, okay, just like in Python, the same thing works here. Let me insert a new thing, new cell below. Suppose in Python, if I say, again, you're int, so A equals to 10, again A equals to 20. Now what is happening in this case? Look at what is happening. So these are basically, if you think about it, A is actually a object of type integer class when you do this. Actually you can print the type of A. The same thing. Actually, why am I complicating it? Print type A. Okay. So if I just do this, one second. Let me just remove this line. Okay. So what is it? Look at this. When I'm just saying A equals to 10, what it's actually creating is, it's basically creating an object. A is actually an object of type int class, right? That's what, again, what we think of as a data type is actually an integer class, right? So what it's doing here, A is the object name, 10 is the value that is stored internally, right? Cool. Now if I override it, now let's, so I already executed this line, insert cell below. So if I execute, where is, sorry, I should go up. Okay, insert cell below. So in this line, if I just say A equals to 20, now what happens? Right, so this A So this A is simply overridden by it. Internally what happens is, internally Python stores all the variables that are there in the given context. So there is something called as a symbol table. Again, I'm going into compiler design. So there is something called as a symbol table, which most compilers and interpreters use. So what they do here is, so as soon as this line got executed, it would create an object name A with a pointer to where in memory this whole thing is stored. Now, when I say A equals to 20, what it's doing here is, this is being changed because I'm using the same variable name, right? In Python, I can override the variable name. The same thing is happening here also. Again, the simplest way to understand it here is in terms of an integer. When you do A equals to 10 followed by A equals to 20, A gets overridden. The same thing happens even with a class, because A is nothing but an integer object to start with, because its data type is integer to start with, right? So I hope this is clear. When you again create another object with the same name, it gets overridden in this case, right? Just like your typical variables, because your so-called integer variable is actually an object of type class int. That again, any such simple questions that you have, you can simply try it with 10 lines, less than 10 lines code, guys. You can easily try it, right? So I wanted to cover a couple of okay, let's cover one more example and we'll pack it up for today. But tomorrow I wanted to explain you about, actually I think I can explain a couple of things. Okay, so let's try to, I wanted to walk you through one more simple toy example so that things become much more clear for you before we jump into the next session. I don't think we can complete everything today. That's why I have allocated 2 live sessions. And again, the lesson learned here is, any simple question you have, sometimes I don't remember all the internals of Python. I just write simple code snippet like this and figure it out, right? So it's very simple. Okay, sounds good. Again, the other way is to read through the documentation. That's certainly one great way to learn. But if you want a quick answer, sometimes instead of reading through lots of documentation, writing a simple snippet of code to figure it out is also easy. Okay, now let's see. Okay, let's see another example from geometry. Again, I've taken this code snippet from OverIQ. It's a very nice toy example. Okay, so first they've created this class called shape. Okay, so let me just scroll this. What happened? My computer stuck. Come on. Wow, my computer stuck. 1 second. Oh, the keyboard is also not responding. Come on. The mouse is not responding. Oh, this is responding. Somehow I think my Bluetooth got disconnected. Okay, that's okay. 1 second. Let me just check if my, I think my, what happened to my, okay, 1 second guys, 1 second. Okay, now it's working. I think small glitch with my keyboard and mouse. My pointer, my notepad is working. Anyway, I'm back. Thank you. I was a little scared that the internet went down or something went wrong and my computer hung up. I've seen, thankfully, my computer hangs very few times, thankfully. So I was shocked. Anyway, so let's go to this code snippet and understand it, right? So simple example. So I create a class called shape, right? This is the constructor. Again, look at the first parameter, always self. Now I have color equals to black. Again, here what am I doing? I'm giving default parameters. We know, right? In functions, I can give default parameter values, right? So color equals to black, filled equals to false. So in self, I'm creating 2 variables, underscore color, underscore filled. And if the default value is black, so in the constructor, the color will be black, filled equals to false. So he's creating a shape object. Look at this. He's creating a shape object. The shape object has a couple of things. It has color. It has filled or not. Color basically says what color is this shape filled with, right? And whether it is filled or not, which is binary, true or false, right? These are the 2 attributes, right? And there are a bunch of functions: get color, set color, get filled, set filled, right? So 4 functions, right? So I'll just put 4 lines here. This is what my shape object, my shape class looks like. Simple, cool. Now what I've done here is this. I've created another class called as rectangle. Again, remember a rectangle is also a shape. So I want to have all of these interesting properties or interesting attributes and functions or methods corresponding to shape also in my rectangle, let's say. So what am I doing here? I'm creating a class called rectangle, but the syntax says that I'm inheriting from shape. That's important, right? So what am I doing? I have my shape here. I'm inheriting into my rectangle class. Now in rectangle class, what do I have? Okay, oh, there is super here. Somebody asked me that question, right? So let me explain you. Okay, so the rectangle class itself has a constructor. This constructor has self, length and breadth. So what are the two important things about a rectangle? Remember, the shape has okay, let me write it down here. The shape has color and filled or not. These are the two things. Now the rectangle, since it inherits from shape, it will also get color, filled and all the four functions. It will get all of that. But the rectangle in addition to that, has length and breadth in addition to this. Now remember, I'm creating two new variables here, which means I get these variables, I get these functions, and I get additional variables and additional functions. Now what all functions I have? Get length, get breadth, set breadth, get area, get perimeter. There are 6 functions here. Now I'm not overwriting anything. Remember, I'm not overriding anything from shape. So in rectangle, because this is inherited, again I'm representing inheritance with this arrow mark. Because rectangle is inherited from shape, rectangle will have color, filled, the 4 functions, get color, get filled, set filled. It has length, breadth and this functionality. It has all this functionality and some other functionality. Cool? Till now everything is okay, right? So now let's go to another class. Okay, the third class here is circle. Okay, so class circle, this is also inheriting from shape, which means from shape I'm inheriting in another class called circle. And what all stuff, oh sorry, before I go there, sorry, my bad. Okay, so there is one more thing I wanted to explain before I go there. There is this keyword super. Okay, so let me explain you how this works. So for example, if I say r equals to rectangle, suppose if I just say this, suppose if I say r equals to rectangle 10, 20. Suppose if I say this, what happens now? Okay, remember, what am I calling? R is an object of type rectangle class and I'm calling its constructor. Its constructor has self anyway will be there. It has length and breadth. So length equals to 10, first parameter, breadth equals to 20. Now, since the rectangle also has color, filled and all of them, I also want to initialize these. Right? So look at this. In this snippet of code, I'm saying self length equals to length, breadth equals to breadth. So I'm initializing the length and breadth in this object R. But there are also color and filled. So if I also want to run my base class, remember this is my base class. If I want to run my base class constructor, I can simply use this super dot. So the super basically means that whatever is the base class. Again, this is the derived class, right? Remember, this is the derived class. So super basically means that I want to call the constructor. Again, underscore init is the constructor. So super dot init basically means I want to call the constructor of the base class from which I have derived, and I'm not passing any parameters here. Okay, so the moment I do this, what happens? The shapes constructor is executed. In the shapes constructor, very importantly, let me just erase this. In the shapes constructor, I don't have to pass anything because this is optional parameter. This is also optional parameter, right? So what happens is in my rectangle, I also have color and filled. Those color and filled will be initialized to black and false, right? So that's the purpose of super. Somebody asked me, how do you call, what if, somebody asked in the comment section in the live chat, what if the base class has a constructor and the child class also has a constructor? It is always a good habit to call the base class or the parent class constructor so that all these variables are also initialized. Simple? Okay. Now let's go to circle. Again, this is a very simple example. Okay. Circle has, what all circle has? In the constructor, you can give it radius, right? It has radius. But remember that circle is inheriting from shape. Circle is inheriting from shape, which means circle also gets color, filled and these 4 attributes. Sorry, these 4 methods. Circle itself has 4 get radius, set radius, get area, get perimeter. So it has 4 functions of its own. Right? Cool. This structure, I hope it's clear. Now let's look at just some class creation, some just object creation. Now imagine if R1 equals to rectangle. So look at the code snippet. R1 equals to rectangle. This is the length and this is the width. Now what are we doing? We are just printing the area, perimeter. How do I get the area? I just say R1 dot get area. How do I get the perimeter? R1 dot get perimeter. Here comes the most important thing. If I just say R1, remember R1 is an object of type rectangle. Now if I say R1 dot get color, first it will go and check in the rectangle implementation if get color is there. Get color is not there because we have not overwritten it. Get color is there in the parent class or in the base class. So it will go ahead and execute the get color from here. So the get color should actually print black because the default value is black. Right? So let's see. If you print it, it will print black. It will print black. Similarly, when I call R1 dot get filled, right? Get filled is not there in rectangle. It is there in the base class. So when I call it, it will go and run the function or the method which is there in the base class or the parent class, or it's also called the super, basically in the parent or the base class. Same logic with circle also. Same code. It's just you're calling the functions that are there here. You're calling the functions that are there here, both for rectangle and circle. Just a very simple explanation, simple concept, right? Now comes another interesting concept. I think I'll cover this, right? So let's cover this. There are a couple of things. Let me cover a couple of concepts, and then probably from multiple inheritance we'll take it tomorrow, right? So the couple of very simple concepts. So till now we came across this case also, right? So let me write that case. Let me write that case. So imagine if I say class, right? My class. I'm just defining a class of my own. Nothing internally. And let's just sorry, my bad. Okay. If I just say pass, it's an empty class. I mean, this is the simplest class that you can create, right? Now after this, imagine if I just say m equals to my class. M equals to my class. Now here comes a small dilemma. Okay, very interesting question. I think I've asked this question just a while ago also. Now my class, in the definition of my class, there is no constructor. But what this should actually call the constructor, this should actually call the constructor of my class. This should actually call the constructor of my class. But there is no constructor of my class. There is no, because I have not defined underscore init here. I have not defined it. There is no definition here. And so what does it execute? But this does not give an error. This runs perfectly. Why? How does it run? So in Python, the logic is this. Any class that you create is by default a derived class of a special class called as object with lowercase o, object. So there is a class called object. Again, this is confusing sometimes. There is a class called object in Python. Look at this. There is this class called object. Every class that you define, every class is derived from object. That's why when you write like this, what this actually means is, what this actually means is internally, when you write something like this without anything, internally the Python interpreter converts this into class, my class, and object. So object is a class from which every class which doesn't inherit anything inherits by default. So object is the parent class or the base class of all classes that you create in Python. That's a very interesting concept. Now there are a couple of very interesting functionality that is there in the object class. The object class has 3 very interesting functions. First function is init, second function is new, third function is str. Again, all of them with double underscore, prefix and suffix. Now what do these things do? So now remember the object class itself, the object class, again this is confusing sometimes, has underscore init. Right? So when you call this constructor, it is going to call the constructor of the base class, which is the object. Because there is no constructor defined here, it looks at its base class. Its base class by default is object. So it will run the constructor of the object class, right? I mean, this is very interesting. Now the object class has three it has many other things, but it has three important methods. Okay, new, init, str. This new function creates a new object. Okay, so actually what happens is the constructor doesn't get called first. This is an internal implementation detail of Python. So when you actually call a constructor, it is not the init function that gets called directly. First, the function new is called. New does some memory allocation and other things, and it then creates this function called as init. So the default constructor for all classes is init. In the init of the object class, there is also a method. I keep calling function because I come from the C++ world. I always call functions, but Python calls them methods. Again, it's the same concept. There are some programming languages that call them as procedures, right? I think Pascal calls them as procedures, if I'm not wrong. Okay, so the str basically is a function or method that is defined an object. Its job is, again, we typically use this to write code to convert any object into string. For example, look at this. Let's actually write this, right? So for example, suppose let me just create a cell here, cell below. Suppose if I just say a equals to 1, 2, 3, 4. Okay, cool. This is good. So I'm just creating a list. So if I say print type A. So what happens now? What is the type? It is, again, A is an object of class list. This much we are clear. Okay. Now if I say print A, what happens now? See, A is an object. So the moment I type print A, look at this. This is very interesting. Okay, with this I'll explain you the context behind string, right? So A is of type, so A, I've created a list here. A, when I type the, when I print the type of A, I know it is class list, right? It is class list, right? So A is an object of type class list, number one. When I say print A, what is being printed? It is printing open parenthesis 1, 2, 3, 4. Why is it printing it in this format? Who told it? Like, where is it defined? That when I print a list, it should actually print all the items that I have in the list in my square braces. Look at this. I did not do anything. I just said print A. I just said print the object. What it printed is actually the contents in the object. Who told it to do so? So in the implementation of class list, right? In the implementation of class list, remember list also, again, there is a concept called as multiple inheritance, but remember that list is also a child class of object, because every class that you define in Python is a child class or it's a derived class of object, and object itself contains this string function. So the people who implemented the list class overwrote this string function. So they would have written def, they would have overwritten it, self of course, okay, and they actually wrote the logic saying we will print all the elements that are there in our list, we will print it in this format, right? So whenever you create an object, or whenever you create a class, if you want an object of the class to be printed comfortably for reading, remember, see, the string function is part of object. Any class that wants to create a functionality to convert an object into a string for printing purpose, oftentimes for printing purpose, right? If you want to implement a functionality of converting any object of that class into a string, you just override this. That's it. So for example, let's take a very simple example here, right? So, okay, let's say class. Imagine if I'm creating this class, okay. Remember, again, it's simple toy example, nothing fancy here. I'll show you a very nice example from Matplotlib just after this. So imagine if I create this class, I've not mentioned anything. The fact that I've not mentioned anything basically means that this has to be object. Now, because this is this is inheriting from the object by default. That's Python's default. By default, object is the base class. Now object has this underscore string, right? So now how am I writing it? I'm overwriting this string and I'm saying just return something, whatever I want. Whatever string I want, I can return it. Now here comes the fun part. Now if I create an object C1 of class with str, again this has no constructor, so it is calling the constructor of the object class. Now the moment I say print C1, look at this, the moment I say print C1, what does it do? It immediately calls, because the print function calls implicitly, it calls the str, the underscore str belonging to this class of which this is an object. So the moment I do this, see, if you want to print any object, you have to override the string. And in general, it's a good habit to do it. It's a very good habit, programming habit, because if you want to visualize what's there in this object, for example, in our short URL, right? In our short URL, I could have, in our short URL class, right? I could have just implemented this function self, obviously. I would have just implemented it, and here I could have said just print the dictionary D. Just print the dictionary D. Then what happens at any point, imagine if I have S1 equals to some short URL, right? S1 is a variable name of class short URL. If I just said print S1, right? If I just said print S1, what would it have done? It would have simply printed the whole dictionary corresponding to S1 object, right? So if you want to be able to print an object, you have to override the str functionality. Number one. Now let's look at, again, I really like matplotlib's documentation because, okay, let's just go here. I want to show you something. Okay, so here is matplotlib, right? Matplotlib has tons of classes. Now here, if you go to it, so we are in the matplotlib module in a submodule called as axis. Okay, so this is one. Again, how did I come here? You can just go to, I think I went to this page, right? And I went to documentation. Within documentation, there is something called as API modules. Okay, I went to modules, I went to axis. So these are all the modules that are there. Modules and submodules basically in matplotlib. Right? Again, we have used matplotlib extensively throughout our course. Right? So if you, again, matplotlib, for those of you who may not know, it's a library that is extremely popular for plotting data in machine learning AI. Now we are in this matplotlib.axis submodule. Within this module, here are all the classes. I really like this diagram. This is the inheritance diagram. This says that there is a class called matplotlib called axis. Again, this is the module, this is the submodule, this is the class name. Module, submodule, class name. So there is a class called ticker, there is a class called artist. From the class artist, again, this is a base class. It has a child class called as axis. This has a child class called as tick. There is a child class of axis called as x-axis. There is a child class to this called y-axis. There is a child class for this called x-tick and y-tick. Again, these are basically your x-axis in a plot and y-axis in a plot. Your ticks are basically what you have here. These are called as ticks, x-axis ticks and y-axis ticks. Right? Here is the whole structure of all the important classes corresponding to this axis submodule. And obviously, if you go down, you get all the attributes. These are all the attributes that you have. Again, in the constructor, these are the parameters that you have. Again, look at this, look at it, it clearly says the class is matplotlib.axis.axis. And this is a base class for x-axis and y-axis. And the constructor has axis and pick radius equals to 15. Again, you may not know all this if you have never written code in matplotlib, but understanding what is a class, what is an object, what is a base class, what is a derived class, understanding it helps you read lots of libraries very easily. Libraries, again, most of machine learning, you will be using tons of others libraries like matplotlib. Matplotlib is just one of the many libraries that you use as a machine learning engineer or data scientist. So to be able to understand the functionality, and even if you get errors, to be able to debug these errors, you have to know the basics of it. right? So these basics I hope will help you. Tomorrow, oh, we have already crossed 8 p.m. Sorry. So tomorrow we'll continue on some examples of multiple inheritance, polymorphism. There is also this concept called as polymorphism plus inheritance. How does it work? Then we'll look at how does polymorphism inheritance works for inbuilt data structures. We'll look at some examples of iterable objects. How do you implement some useful, how do you make your class objects, how do you create iterable objects and things like that. Again, I'll try to walk you through both toy examples and real world examples, right? So I'll share this notebook till wherever we have completed till now in about 10 minutes after this live session. And okay, sounds good. So anyway, some of you have questions. How do we override the str of this? You can do it, right? So how do you, let me take a couple of questions. So if you want to override this, right? If you want to override this, you just, so the question here is, how do you override _ str of numpy nd array, right? That should be easy. The way you do it is you create a subclass for nd array, right? For example, if you're not happy with the way numpy prints, with the way nd array's string prints, right? So what you do is simple. You just create a new class called as my nd array, right? You just make it a child class of numpy.ndArray, right? In here, you only override the str function. You only override the str function, of course, with self, and whichever way you want to print, you print it. Sorry, I'm writing again C syntax. Sorry, there should be def here. Again, I'm just explaining you, right? So the basic concept. So what you do here is you're creating one more subclass. Again, this is your base class. You are creating a subclass, your subclass of ndArray. You're only overriding the _ string. However way you want to print, just print it. Again, that's a good example. That's a very good example. Okay, so sounds good. Let's again, I'm sorry I've overshot a little. I'll provide this notes, and tomorrow we'll cover some more concepts. Hopefully by tomorrow end, I hope to finish all of object-oriented programming, and in the next sessions we'll cover other topics. Okay, thank you folks, thank you very much. Again, just before I leave, very importantly, it's important that, again, the reason I'm covering some of these from a very basic level, unlike other sessions, is because it's something that we hope will help many students use and extend libraries that are already there to match their needs, right? So I hope that helps. Sounds good. Thank you very much.